I'm going to prove that this function, which we've seen before, is integrable on negative 1, 1, which might be a little bit surprising. Remember, this function looks like it goes and then it gets like that, and then over here it does the same thing. It goes up, down, and then it kind of speeds up like that. And then there's one final piece. It's 0 right at 0. Okay, so the strategy that I'm going to use is I'm going to split this into 3 distinct parts. I'm going to go from negative 1 down here to negative epsilon over 8, and then I'm going to go from negative epsilon over 8 to positive epsilon over 8, and then I'm going to go to, I'm going to also look at purple, how about epsilon over 8 over 2, 1. So I'm going to break this up into 3 pieces. And the proof is on the interval, say epsilon over 8, comma 1, f is continuous, because the only bad part is really at 0. So it is integrable on epsilon over 8, comma 1. So there exists a partition about p0 of epsilon over 8, comma 1, such that uf of p naught minus, I should start my proof with let epsilon be bigger than 0. And then epsilon over 8, all this stuff makes sense. So I'm defining epsilon, pick whatever epsilon you want. I'm going to prove, well, my last phrase will be uf of a partition minus lf of a partition is less than epsilon, so f is integrable on negative 1, comma 1. That's going to be the last line. So I'm going to start with a p naught, and right, this is going to be, I can make this given an epsilon less than, say, epsilon over 4. Remember, this is only on epsilon over 8, comma 1. And very similarly, there exists a p1 of negative 1, comma negative epsilon over 8, such that uf p1 minus lf of p1 is less than epsilon over 4. Great. Wait 1 second, I'm going to think for a second. I'm done thinking. I just thought that maybe I'd made a slight miscalculation, but I hadn't. Then let p3 equal the partition negative epsilon over 8, epsilon over 8. So it's the easiest partition of this middle thing that you can imagine. It just has the endpoints. Then uf of p3 minus uf of minus lf of p3 is going to be equal to, well, right, you find the upper sums. The upper sum, right, we're talking about the sign, so the biggest thing anywhere is 1 times the interval of length of the interval, which is epsilon over 4, minus the smallest thing anywhere, which is negative 1, because again we're talking about sign, times epsilon over 4 equals 2 epsilon over 4 equals epsilon over 2. So now I'm going to let p equal p1 union p2 union p3. Then what I have is union, or fp minus lfp. You can split this up into all the different ones. Basically, it breaks down to is less than or equal to the sum of these. So over here for the blue, you get epsilon over 4. Over here, you get epsilon over 2. And again, over here, you get epsilon over 4, which equals epsilon. So this thing is less than epsilon, so f is integrable.